Dear colleagues, I'm going to talk about Mackey-Glass type generators system, and by Mackey-Glass type generator, I mean an electric generator which is described by the violet equation. Here, function V is a voltage function. It depends on time. Parameter gamma determine the form of the nonlinear function. Tau is time delay. C is a feedback strength, and beta is RC constant in the system. This is an equation first was considered by Mackey and Glass in their work 1977, and their unknown function models concentrate of blood cells. I mean that this equation first come from medicine, but later it was considered as model of electric generator because it allows to model chaotic signals. It is possible to make circuit of such generators, and first I consider circuit of 4 generators. Here, two drivers and 2 responses. Such model was considered by Sano, Uchida, Yoshimori, and Roy in 2007. Drivers is modeled by the first 2 equations, Brown equations, and responses is modeled by gray equations. Here you can see that green terms models coupling of generators, and every generator have time delay loop in nonlinearity. The first 2 equations is split off from the system, and it is possible to consider them as a split off system of 2 generators for analyzing. They construct dual synchronization of chaos for such system, and they get synchronous regime mode for VD1 and VR1, the same for second pair of generators, driver and response. And you can see that first driver and the second response not synchronous. Also, it was considered a circuit of 2 generators by Tatena and Uchida. Here you can see 1 driver and 1 response, and an analogous system to model such circuit. Here also green term means coupling between generators. Kappa is coupling strength, and by WD1 and WD2 calls feedback strength. Here they make chaos synchronization in this system, and they also get numeric results. And now I want to describe the object which I consider in my work. I consider the ring of Mackey-Glass generators, and every generator have one and the same type, and every generator translate signal to the next generator, from V1 to V2, from V2 to V3, etc., and from Vm to V1. We have M generators. G is from 1 to M. And here green terms also means coupling. In particular case, it is possible to consider pair of such generators. We have only two equations in this situation for V1 and V2, and every generator is coupled with other, V1 with V2 and V2 with V1, and we have delay in a coupling. This delay is tau 2. The task which I consider yes, I describe it soon. At first, I want to suppose that every generators are the same. I mean that my assumption that every AG is one and the same A, the same assumption for B, C, and gamma. Also, I make normalization and substitution and time normalization to make the system simpler. Besides, I suppose that gamma, this parameter in a power, is smaller, is a big parameter. And the task which I want to consider about traveling waves, I want formulate not for essential object, not for this system, but for limit object. When I suppose that gamma is big enough, I introduce function f as a limit of this function, 1 divided by 1 in power gamma. This is a threshold function, which is 1 when argument is from 0 to 1, and this function is 0 when u more than 1. It is possible to consider such system as also as a system which models generator's behavior. And I investigate this system analytically. My task is construct discrete traveling waves. Such solutions I guess first was considered by Glizin, Kolesov, and Rozov. I want that unknown function UG will be the same function u with a shift. Every function shift by delta from the previous one. And this parameter delta will be determined. When I make such substitution and suppose that every UG is described by such function u, I can consider auxiliary equation star and find a periodic solution for this equation. When I find a periodic solution, then I go back to the system and can prove existence of discrete traveling waves. I want I'm looking for a periodic solution, and I have a ring. That's why U2 is the same that U0. It means that value to delta is several period of function U, and delta satisfies the period equation to delta equal P multiplied by T, where T is a period of function U and P is some integer number. And when P equal 1, I have antiphase solution. I mean that U1 and U2 is shifted from each other by a half of period. This is also a particular case. And I have, I can define initial functions. This is a set S, such functions that sum of phi with shifted arguments by 1 and shifted arguments by h more than 1. This is a critical one, is the critical value for function f. And I proved the theorem about this auxiliary equation, and I forget to say that h, delay h is tau plus delta, and it is important that h dependent on delta, and delta is now unknown parameter, but it is task to prove that this delta exists, which satisfies period equation. And result is the following. If h is from 1 divided by 2 to 1, and exists alpha, beta, then this auxiliary equation with initial function from S has an orbitally stable periodic solution, a function U star, such that contains 4 parts. The first part is exponent. The second part, linear function multiplied by exponent. The third part is a quadratic function multiplied by exponent, and the last again exponent. Here A, B, C, D, E, G, and H are constant, which dependent on alpha, beta, and H. This equation have a stable solution in this form, and it means yes, and I want to show you illustration of this result constructed with Mathematica. The previous result is analytical, but I can show illustration and make numerical experiment. Such solutions, as I said, with exponent and other pieces for different values of parameter from the parameter domains. And also, as I said, when I go back to system, I should prove that such delta exists, and next theorem is about it, and it is exists such delta which is half of period. The same result is possible to prove for arbitrarily M, I mean for a ring of M generators. This is all. Thank you for your attention.
Okay, let's thank the speaker. Really made an effort to prepare such a beautiful calligraphic presentation. Any questions? Okay, there are no questions, so thank you so much.